Good afternoon. Good afternoon, friends. So, in the previous lecture, we studied about mechanics. Now, we will move one step forward. What is uniform motion? If an object is covering equal displacements in equal interval of time, then it is known as uniform motion. Then we have uniformly accelerated motion. The difference between the two is like uniform motion, if an object covers x distance in 1 second and in the second it covers again x distance, it is known as uniform motion, means uniform velocity. The another one is uniformly accelerated. Uniformly accelerated motion, it has constant acceleration, means the speed changes uniformly. Every second or every unit of time, the speed is changing at a uniform rate. That is what is constant acceleration or uniformly accelerated motion. This is the basic assumption which we will be putting forward to know the basic three equation of kinematics, which are V is equal to U plus AT, V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. What are these three equations? This equation is velocity time relation when A is constant. If we consider A is constant, then we find out that as per the time how velocity is changing. So why it is being followed like that? Whenever you will be solving a question, you will be getting some information. You have to judge that you have been given with the time and velocity, time and acceleration, time and speed, what you have been given with. So if you are given with the information of an acceleration, velocity and time, then you have to follow this equation. If you are given with that position or distance and time with that particular velocity, then you have to find out what position time relation, that is this one. And this is what? Position velocity. So if position and velocity is given to you, you have to find out the third variable. You will be using this equation. But now the question is, these equations are very easy to cram. But the main issue is how we derive these equations, how we come up to this particular equation. That particular concept will help you to solve a particular equation, because these are the equations which are the base of this kinematics. So we will take them one by one. Let us take first one. V is equal to U plus AT, that is velocity time relation. This equation says what? Velocity, which is final velocity, V is final velocity, U, which is initial velocity, that is the velocity when the measurement or the observation was started. Why I said the observation was started? Because whenever you talk about physics, there is just an assumption that this is t is equal to 0, but actually the world is moving, everything is moving. We consider that the car was, or any object was moving with a certain velocity, and we observed that particular thing at a particular time. That we consider the initial velocity. Now it is 0, then it is 0, maybe car was at rest, maybe the object was at rest. Later on stage, we find that only assumption which you have taken is uniformly accelerated. So A is the constant acceleration. And T is what? T is change in time. Let us say 10 seconds were already passed over this situation, and we are measuring at 20 seconds. So we are measuring at two locations. 10 second when the initial velocity was calculated, and 20th second when the final velocity has to be calculated. So the total time change is what? 10 seconds. So this is time span. Okay. Now, how we arrive at this equation? You already know that acceleration is equal to change in velocity per unit time. It may be written as V upon T is equal to A, means change in velocity. So V2 minus V1 we can take, or if V2 is the final velocity, it can be written as V. V1 is the initial velocity. Why? Because change in velocity. This was the first one observed, right? This is initial velocity. Or it can be written as U. So what it becomes? A is equal to V minus U upon T. Now what is T? T is T2 minus T1. If we consider T1 is equal to 0, why? We consider that T1 is equal to that particular time when the motion was actually started. Let us assume. So T1 will be 0. 0th second. T2 will be the final time. Let us take T2 is equal to T. It becomes V minus U upon T. I just explained how this T is arrived, nothing else. So this implies V is equal to U plus AT. Simple. We cross multiply this and we add this U to just carry forward it to the right side. This equation is derived by just the logic. This is one way to derive this equation. How it will help you in solving a question? Let us take an example. Let us say an object is moving in a straight line. In a straight line again, we are considering only translatory motion here, not circular motion nor oscillatory motion, only the translatory motion. Let us say object is moving with a speed of 20 km per hour when we observe at particular time 10 seconds, let us say, and we observe here the time span is 25 seconds and the speed is what? Speed is 28 km per hour. Now it was 20 km per hour. Now it is 28 km per hour. Okay. What we have to find out? Acceleration here. How we will find out? We have what we are given. V is equal to 28. U is equal to 20. A we have to find out. T is equal to 25 minus 10 is equal to 15 seconds. Now this is in second, this is in kilometer per hour. So we have to bring it to the same unit. If it is in hour and it is in second, either we must convert this second to hours or this hour, kilometer per hour, to meter per second or kilometer per second. It's up to you. This kilometer can be kept constant. We have to convert this hour to second or this second to hour to bring it on same line. What we'll do? Let us convert this into meters per second. This will be the formula. How we are derived at? Kilometer. 1 kilometer has 1000 meters. Done. Hours. 1 hour has 3600 seconds. But it is in denominator. So it will be divided by 3600. But it is in numerator, kilometer. When we are converted into meter, it will be multiplied by 1000. As simple as that, we have obtained this particular solution. What it will become? It becomes 70 by 9 or approximately 7.77 meter per second. How about this? This again becomes 50 upon 9, which is approximately 5.55 meter per second. Now, when we are having the final velocity, initial velocity is given, time difference is given, we can easily find out A using this equation. V is equal to U plus AT implies A is equal to V minus U by T is equal to 7.77 minus 5.55 whole divided by your 15. It becomes 2.22 divided by 15, which will be approximately 0.15 meter per second square. So this is the way you can easily calculate if you are clear about the concept. It is a very simple question. No matter how much complicated the question comes, just observe and you can easily find out that these are the concepts, basic concepts. We are using those concepts and we are arriving at the answer. It is as simple as that. No constraints, no difficulties, nothing. Thank you. We will take up the other equations in the next lectures. Thank you.